Okay. Very good morning to one and all. In the last class, we discussed about the resistance welding. We have seen how a resistance welding works, isn't it? Especially the heat generated for the welding. So it uses, first of all, it utilizes, compared with the other welding process we learned, it utilizes the heat and pressure, combination of heat and process to accomplish the coalescence between the workpieces which is in contact. And how the heat is generated? It is generated by the electrical resistance to the current flow at the junction to be welded. So what I shown in this picture is so the resistance welding is commonly known as resistance spot welding, which I have mentioned while discussing in the last class. So what I shown here is a machinery which is utilized for resistance welding process. The left one shows a schematic diagram and the right one shows an actual diagram. You can see, just look at the nomenclatures I pasted. I will get back to this diagram soon while discussing the working. Please have a look at this. Now I told you already, this type of welding process can be used to join two metal plates in a lap joint by forming a small nugget at the interface of the plates. So this is how a resistance spot welding works, and you can use this resistance spot welding process to weld low carbon steel, high speed steels, stainless steels, aluminum, copper, nickel, and their alloys can also be spot welded. And you may please note that the plate thickness up to 3.5 mm is considered as suitable for spot welding. Yeah, for example, this is another important information. You can weld a number of spot welds on the same pair of sheets. So when a number of spot welds are made on the same pair of sheets, then there will be a chance of completing the electric circuit through the already formed nuggets. Okay, so I hope you are remembering what is nugget. When two welded plates being joined, that region. Now, as I told you, you can use this spot welding to make number of nuggets, number of spot welds are made on the same pair of sheets, and there will be a chance of completing. So, which means the electric current is passing through this. The resistance to the electric current is, and which causes the heat to come, and then it metal melts and joins. This is how welding takes place, isn't it? And when for example the first weld is completed, and when you are going to do the second weld, there is a chance that the electric current may flow through the first formed nugget, and that region may again get welded, and that special effect is called the shunting effect. It's a very important phenomenon in resistance spot welding. Now, to overcome this problem, the magnitude of current is increased from second weld onwards. The current which you allow to flow through the plates, compare with the first spot weld, the second spot weld onwards, it increases. So it avoids the shunting effect. And also another important feature information we can remember, this is maintain proper distance between consecutive spots. This also will help to avoid shunting effect. And yes, definitely the electrodes are used in spot welding, which is shown in this picture. These are the two electrodes. So look at the schematic diagram. In between, the workpiece is going to work, and the lower electrode is held by lower horn, and the upper electrode is held by upper horn. And there is a rocker arm which operates the upper electrode, which moves up and down. You can see this motion is represented here, and usually this welder is operating this machine using a foot pedal. You can see he will press this foot pedal and the rocker arm gets initiated, and there is this is a pneumatic type. So once he press his pedal, because of the pneumatic action, so you can see a pneumatic cylinder here to actuate the rocker arm. This is how it works. This is how a close look at the electrons. These are the two electrons which is used in this electrode spot welding, resistance spot welding. And what are the functions of electrodes used in spot welding, and what are the different properties of the electrode materials? First function of the electrode is to transmit the current and force to the work materials, because as I told you already, it's a combination of heat and pressure that will help you to establish the coalescence between the workpieces in contact. So the function of the electrode here is to transmit current and force. The current is passed through the electrodes, and also it also squeezes the workpiece, and dissipate heat from weld zone. Yeah, it helps to dissipate heat from the weld zone, the electrodes. And if you look at the properties, what type of electrode material you needed? You need the property which you needed for the electrode material are electrical conductivity. Its conductivity should be high, thermal conductivity should be high, strength and hardness at high temperature. It should be able to withstand high temperature, so it should have high temperature strength and high temperature hardness, and minimum tendency to join with the metal being welded. Which means the electrode should not touch the workpiece and pierce into it. And another important information I would like to share with you: what are the different type of different typical shape of spot welding electrodes? One is called a pointed, and the other one is dome shaped and a flat ended. You can see pointed shaped electrode looks like, domed shaped electrodes looks like, and you can see flat shaped. So some of the pointed shape electrodes are depicted below. Now actually this is shown here to explain another important effect. So these are three types of electrodes used: pointed, domed and flat. For different applications we use the different type of electrodes. And then among this pointed type electrodes are widely used, and there is a chance in the pointed electrodes, due to wear, the area of pointed end gets enlarged. So in order to showcase that effect, I shown all these videos here, all these photos here. You can see because of the because this electrode is not only a carrier of electricity, but also it applies the force to the workpiece in contact. So maybe continuous usage will cause the wear, and due to wear the area of pointed end gets enlarged and flattened uniformly. You can see that effect. This is called mushrooming. So domed electrodes can withstand, whereas the domed electrodes can withstand high pressure and severe heating without mushrooming. But the pointed electrodes are comparatively cheaper. And let me take you to we will discuss the seam welding in the next video. Thank you.